Uh, any questions regarding the homework? Aaron?
2.6, number 21 and 29.
Oh, I didn't share my screen. That. All right. Now, what did I say? Oh, it's gone. Well, number 21. Find the vertical asymptote and the horizontal asymptote. All right. So 21 is find the vertical asymptote and the horizontal asymptote of 6x squared plus 20 divided by x squared minus 5x plus 6. Okay, so we have two things, horizontal and the vertical asymptote. For horizontal asymptote, this is something we had done before. We set the bottom to be 0 because we're trying to create something like 2 over 0. Clearly, that's positive, negative, infinity. Clearly, it's a vertical asymptote. Okay, to do that, we try to set the bottom to be 0. So far, so good. We are dividing by 0. It's possible. Second thought, wait a second. This gives me a vertical asymptote. But if I'm unlucky, I may have 0 over 0. This gives me a hole. Still okay? We just checked the bottom. We still don't know the top yet. So there's one more job to plug this one back to the top and make sure you don't have 0 over 0 case. As long as it's a number over 0, infinity, vertical asymptote. Okay? So this one plus 20, that's the top. You plug in 2, you plug in 3, you find it's never 0. Then both of them are vertical asymptotes. Answer, the vertical asymptotes are x equals 2 and x equals 3. You have 2. If you end up having 0 over 0, you need to say that it's a hole. It's not a vertical asymptote. All right. Now for horizontal asymptote, we had this before, right? Horizontal asymptote is what happens at infinity and negative infinity. That's why we have at the most 2. So you just need to check this. And this. One for the left, one for the right. We do this by leading terms. We have 6. We have 6. So that gives us horizontal asymptote is y equals 6. So 2 and 3, y equals 6. That's 21. Are we good? Let's go with 29 then. Evaluate the following limits. Okay. Question. When x goes to infinity, what about this part? Infinity. What about this part plus 3? Infinity. What about the whole thing? It's roughly 9 over infinity. The answer is 0. Okay. Same thing, but this time x goes to negative infinity. You need to ask yourself, when x goes to negative infinity, what is e to the x? To the left. Goes to 0. Therefore, 9 over 0 plus 3, this is 3. So before you get excited and go ahead and do anything, make sure you know where it's going to. That should be 3. That's 29. All right, Nick, what do you have?
I had number 4 and number 11 from 2.7.
7. Number 4 and the number 11? Nick, is it number 11 or 7? 11, okay.
4 and 11.
The displacement of particle moving in a straight line is given by the equation S and, okay. Distance of a particle is given by St equals 1 over t squared, where t is measured in seconds, okay? Find the velocity of the particle at time t equals a, t equals 2, t equals 3, and t equals 4, okay? So find the velocity at t equals a, 2, 3, and 4. Now we have done this before. We know when you say try to find the velocity of a distance, you're trying to find the derivative of that distance formula. In this case, 1 over t squared. Sounds good? Then all we need to do is calculate limit h goes to 0, f a plus h minus f a divided by h. That will give you the velocity at a. Then we put in a equal 2, a equal to 3, and a equals 4 to find the corresponding numbers. Okay. The rest is calculation. 1 over a plus h squared minus 1 over a squared h. Common denominator. A squared minus a squared plus 2ah plus h squared divided by a squared a plus h squared times 1 over h, which is the same as dividing by h, equals, they cancel. You have negative 2ah minus h squared on the top, and another h at the bottom. A squared, a plus h squared. The top now have h negative 2a minus h. You have h, they cancel each other. Negative 2a, 0. A squared times a plus 0 squared. That's step one. Clear? Cool. For 2, 3, 4, just plugging a equal to 2, 3, and 4. You got all the corresponding ones. All right. Now for 11. If you toss a rock at initial height with the initial velocity, then its height after t second is given by the formula ht equals this, where g is this. Okay, so here are you toss a rock. Okay, the height is a function of t. It is given by where, I better put this, where this is h. You're standing on a building, you toss a rock with initial velocity v. All right. Now we need to do several things according to Weberg. The first one, they ask you, what is h0? Then you just plug in t equal to 0 in this. You find it's 1/2 g0 squared plus v times 0 plus h, which is just h. That means at the initial time, you are just here. Okay? You just toast. It hasn't moved yet. Second, the velocity vt is h prime t. So you are trying to find vt, which is h prime t. And you have nothing better but doing limit h goes to 0. V ht plus, let's take this to be, I don't know. Let's pick a letter. Let's pick it to be G. The original thing has a G too, so let's change another name. Let's still use H. But I just copy this thing so I don't have to name it. Okay, I basically put t plus h for the first part and t for the second part divided by h. Okay. Through some algebra, t squared plus 2th plus h squared plus vt plus vh plus h plus 1/2 gt squared minus vt minus h. Now they cancel. They cancel. They cancel. So what's left is negative gth minus 1/2 gh squared plus vh divided by h. That's the second one. Nick, is it all right? For
Yeah, there's just a lot of steps.
I would say copy this down Or you can watch the lecture later. You have all the steps, just follow them. I'm pretty confident this is correct. And then you need V0, which is just V minus G times 0, which is capital V. And finally, for number 4, you're looking for V prime t. You just repeat limit h goes to 0. V t plus h minus vt divided by h, where for v, you plug in this. Negative gt plus h plus v minus negative gt plus v divided by h. Choo, 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 choo. All right. That's all the answer. And they're all correct. Good. Do you like it? We certainly need something better. We don't want to do this difference quotient every single time. It's freaking long. Okay. Good news is we have chapter 3. So we can actually next time do the derivative really fast without going over this. Okay. And the way we do it is actually going over it for one last time for any general case. So we can skip that every single time. All right. Austin, what do you have?
2.5 problem 4.
Find the point at which this one is discontinuous. I think we went over this one in class. Would you mind just remind me at the end of the class so I can go over just yours?
Yeah, that's fine.
Cool. Sounds good. All right. That's all we have from the homework. Just some heads up. Exam 1 will be next week, Friday. It will cover 2.1 all the way to 2.7 and 8, which is what we finished yesterday. Okay. For the format, just go to the instructions. Basically, 5 minutes before the class starts, I send you the exam. You just answer all the questions on a sheet of paper. When you finish, I give you another 10 minutes to take a picture or scan it and then submit it online on Canvas. Okay. Writing project. This is the first one. I made it due 1 week after the exam. The exact due date is on Canvas. So you can just focus on the exam for the next week and worry about this one later. Okay. I personally suggest you start early because this is the first time we do it. Submission can be a problem. Communicating with your team member can be a problem. Typing can be a problem. Anything can be a problem. So we prefer to actually see it as you go as early as possible instead of say, hey, it's due tomorrow. And on Friday, you send me an email asking me, how do you want to type this? Okay. In that way, it's going to be really short-handed. Yep. Okay. Before we go on, any questions regarding the exam? All right. By the way, during the exam, I will still open this Zoom, so feel free to join, just in case you have some questions regarding the exam. Okay, so say, hey, what do you mean by number 4 or something like that? I will still be here during the exam, so you can ask questions. Let's try to make the first one work. Okay. How we know this? All right. Then you do it again. Then you do it again. And then you see the trouble of this, right? It's so difficult. It's so long. It's kind of redundant. We wish we have a shortcut. Just by seeing this, we take a formula and automatically we get the derivative without having to go over all this again, and again. And we just showed one from Nick's example. It's a pain in the butt. That's what we're trying to do now. Okay, with chapter 3. Sounds good? What's the plan? The plan is simple. Number 1, we do it for all simple functions. We do it for polynomial. We do it for rational. We do it for exponential. And then we do it for trig. We do it for radical. We do it for log. We do it for trig inverse. So that's the 7 elementary building block we need to finish first. Okay. After that, what do we do? We do f plus g, f minus g, f times g, f divided by g, and finally f circle g. Still okay? Then eventually we will be able to handle something look like this. Derivative. Okay, it's freaking complicated, but if you just look at it, it's nothing but one of the 7 simple functions, plus some way to combine them together, which are all included in the differentiation rules. All right? That's clear. Okay, some rough plan. We will do polynomial, exponential, f plus g, f minus g in the first section. We then do f times g and f divided by g in the second section, which is called product rule. We then do trig for a whole section. We then do f circle g, which is called chain rule. Okay. Then we deal with 3.5 and 6. That is implicit differentiation. It's a fancy name. But really what it says is, if you know fx, how do you find the derivative of f inverse x? Okay. Because if you can do that, that means if you know exponential, you know how to do log. And if you know trig, you know how to do trig inverse. Make sense here? So that's exactly what we are planning to do, the whole list. It's just we order them a little bit differently because this time, some of them are more difficult than the others. We go over the easy ones first. Okay, so all the list is mixed in the process of doing this from 3.1 to 3.6. Once we finish that, we just do one more. That is optimization applications. Then the whole chapter is over. Okay, so keep this list in your mind. We're just going to fill them all as we move forward. Let's, of course, start from the easiest one, polynomial. Derivatives of polynomial and the exponential. Okay, of course, number 1, polynomial. What's the derivative of this? All right. To get the derivative of this, we decompose it into 2 problems. The first one is, you know, polynomial is nothing but a lot of powers put in together. We have 4 powers here, 8th, 4th, 1, and 0 power. Good so far? So the first thing we do is we deal with power, which means just one term. We need to be able to handle anything look like x to the n derivative. The formula is actually given by this. Once we know that, we know the derivative of this. We know the derivative of this. But how do you make the derivative of x to the 8 plus 4x to the square? That's the case where we need two rules. The first one is how do you combine the sum? Okay. The second rule is how do you apply the rule after timing a number? Sounds good? Okay, so that's the logic. We first handle each individual power. Then we find a way to putting them together by taking the sum, taking the subtraction, or times it by a constant, which we will know. They're all simple rules. That's the logic. All right, let's start with the first one, power. Anything look like this? Well, let's do several simple cases. Number one, what if n equals 0? Then it's x to the 0 to the prime. Wait a second, x to 0 is what? Is 1. What is the derivative of 1? Well, this is y equals 1. What's the changing rate? Never change. Sounds good? So that's the first rule. The derivative of constant is 0 because it never changes. Pretty easy. Number two, what if n equals 1? What's the derivative of x prime? Well, this is x. You asked me the changing rate, right? It's the same as the slope of the tangent line. Still okay? What is the tangent line of this line? That's the same line. Sounds good? Then what's the slope of the red line? It's the same as the black line. It's the same as the slope here. So the answer is 1 because the slope of this one is 1, which is the same as the tangent line. So this is another fact. The changing rate of linear function y equals ax plus b is a constant. And the constant is exactly the same as the slope. Which kind of makes sense, right? The changing rate of a line is, of course, a constant. Cool. Number 3, of course, we want to handle the general case. That's where we have x to the n, including x to the square, x cubed, x fourth, and so on, for n equals 2, 3, 4, 5, 6 for integers. And if we want to do that, the derivative of this is nothing but this, 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 and this. Now we do this once for all for any n. Okay. It's going to be long. Try to follow. And we're not going to require you to know the proof or anything. Just for this one time. Try to see where it come from. Okay? And this is what we do. We take n equals 2. Okay? We have x plus h squared minus x squared divided by h, which is x squared plus 2xh minus x squared divided by h. They cancel. 2x plus h. Okay. You let h goes to 0. This will be your derivative. N equals 3. X plus h cubed minus x cubed divided by h, which is x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. They cancel. 3x squared plus 3xh plus h squared. Once you divide by h, when you let h go to 0, only this one left. Still okay? Let's do one more. Okay, they cancel. This is fourth, and this is cube. After you let h goes to 0, only this one is left. Trust me, on my calculation of foiling everything out. Okay, that is correct. But once you admit that, do you observe a general pattern? What's going on? Do you observe that? Well, several things. Number one, the first term always cancel. Which kind of makes sense, right? If you have x plus h to the nth power, the first term will be the same as the term here. So they always cancel each other. So we don't have to worry about it. Still okay? After that, you have a lot of terms left. Okay, what are they? They are a combination of x and h. Just different number of x and different number of h. For example, this term, you have 1x, 2h. This term, you have 3h. This term, you have 2x and 1h. Still okay? But the good news is, actually none of them better except for the first one. Can you see that? Why? Because only the first one has 1h. And then you divide by h. Then that h is gone, you have some term. All right? What about the other terms? The other terms has 2h. You divide 1h, you still have 1h left. Or they have 3h. You divide by h, you have 2 of h left. They will always have some h left. Maybe 1, maybe 2, maybe 3, maybe 4, maybe more. Still okay? But then remember the last step, what do? You let h goes to 0. As long as you have a relationship with a h, you're gone. Make sense here? So they will be gone, they will be gone, they will be gone. Why? Because you have a h left. There's only one term which does not have h left. That is the one originally only have one h. And once you divide, it's gone. Make sense so far? So here's the logic. Finding the derivative of all these things is exactly the same as finding this term, which is exactly the same as finding this term, which is exactly the same as finding the second term. Of this. Because the first term will be gone. The third term and the fourth term will be gone when you let h goes to 0. Only this second term matter. Make sense so far? All right. How do you do that? Well, this is how I did it. Number one, if it's x plus h squared, I follow it. I know this one will be gone. I know this one will be gone. So I'm looking for this term. Cube. I know this one will be gone. I know everything after that will be gone. Therefore, I'm looking for this term. Okay, fourth, fifth. Now for n, I know the first term is going to be this. I know the second term is going to be this. I know the third term will be, I don't care, they will be gone. I just need to know the term here. Good so far? Moreover, I just need to know the number here. What is that number? Seems like for this, it's 2. For this, it's 3. Right? I just need to know that number. Period. Sounds good? Okay. Now, we just need to figure out how to find that number. Well, how did you know this is 2x plus h? How did you know this 2? Think about it. This is what you do, right? Now, how do you FOIL them out? You take a x, you take a x, you got x squared. You take a h, you take a x, you got a hx. You take a xh, you got a h squared. The 2 come from this one repeated itself for twice. Right? How do you do it for cube? How do you FOIL it out? Well, you take a x, you take a x, you take a x. That's how you got x cubed. Right? Then you take a h, you take a x, you take a x. That's how you get hx squared. All right? And then you take a x, you take a x, you take a h. That's how you got x squared h. That's how you got. Do you realize what you're trying to do is you have so many factors, and in each factor is either x or h. You just pick either of them. And what do you mean we're done? That means you run through all the possible combinations of which one you pick x and which one you pick h. Does it make sense here? Okay, so what do you mean by x squared h? Well, that's 3 possibilities. It's x, x, h. H come from the last one, or it's h, x, x. H come from the first one, or x times h times x. H come from the second one. Because I need one h and all the rest to be x. Good so far? How many times? 3 times. That's why it's 3x squared h when you finish. Good so far? What about n? That is x plus h, x plus h, x plus h, and dot, dot, dot. Okay, the first one is this. The second one is xn plus 1 times h. What is that? That is x times x times x times x for n minus 1 times, then times another h. All right? Where can the h come from? The h can come from the first interval, with the rest being x. H can come from the second interval, with the rest being x. H can come from the third interval, with the rest to be x. Can you see that? How many possible ways are there? Well, h can come from the first, the second, the third, the fourth, the fifth, how many different possibilities? Because I have n intervals. H happen for once. It can happen from the first, second. I have n possibilities. Combine them. It's going to be x to the n plus n times xn minus 1h plus the rest, which I don't care, and this one will be gone, which I don't care, and this will be my derivative, one side divided by h. Does that make sense to everybody? You don't have to reconstruct this, okay? If you're still kind of shaky, go back, rewatch this lecture, especially this part, okay? You just need to get a feeling of it so you trust it. But nonetheless, we finished. What we figured out is the first term is gone, the rest is gone. We only care about this one. Dot, 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 divided by h. This one has an n in the front. Once you divide by h, it's this one plus dot, dot, dot. And when you let h go to 0, they're all gone. So this is the formula. For n equals 2, 3, 4, 5, 6, 7, and so on. Okay, and the technique we used was we tried to FOIL something out and focusing on only one terms. Questions?
Professor, I think your mic's muted.
Sorry. Can you guys hear me now? Cool. Yeah. This is a nice formula. This formula works for 2 to 7 and all the integers after that. Still okay? Now we still are missing some integers. Number 1, does it work for n equals 1? We can just quickly check. If we trust the formula, the derivative should be like this. Our answer will be 1. Is this the right answer? We just did it, remember? For a line, it's the same as a slope. This is correct. So we can add this one to the collection. It works for 1. What about 0? That means x to 0 prime should equal 0 times x 0 minus 1, whatever, it's going to be 0. That's what we got from the formula. Is it correct? Basically, you're saying 1 prime is 0. 1 is a constant, right? So this also works for n equals 0. We can add this to the collection. Okay. Does it work for fraction? Does it work for when n is negative? Does it work for a rational number and irrational number? Okay. We don't have the mathematical tools to check this, but the answer is yes. Therefore, finally, we have this general rule of power. Power differentiation. That is x to the n prime equals n But this time, it works for any number. Feel free to use it. We only prove the integer case, of course, but it's working. Cool. Let's try to see some quick examples. What's the derivative of x squared? No difference quotient, no limit. It's n x n minus 1. 2. Good. So basically, you take this number down and you reduce it by 1. That's how you got this. Okay. Square root. How do you do it? Conjugate all the stuff. It's a lot of stuff, right? Now forget about it. It's a power, right? Your n is 1/2. Does the formula work for 1/2? It works for any real number, so this is going to work. Just make sure you put them in the right way. And then trust your formula. And we had this one in one of the web work. If you still remember, this is the correct answer after you use the conjugate. But now we don't have to do it anymore. Sounds good? Finally, back to the question Nick asked. What's the derivative of 1 over x squared, remember? The one with the a, 1 over t squared. Our final answer is negative a cubed, something like that. We went through a lot of algebra. Okay. Now forget about all of them. This is the power. With your n equals -2, then it's working. Okay. That was what we got before with the a. This one, just get it right away. You skip all that. Sounds good? From now on, you can trust all this. Now, by the way, do you still remember this one we just did, which was a pain in the butt? Now, what's the derivative? Well, for the first one, these are constant. The derivative of t squared is nothing but 2t. For the second part, v is a constant. The derivative of t is nothing but 1. The derivative of h is 0 because it's a constant. So the final answer is this, which is way better than what I showed at the beginning. Okay. Of course, we're not there yet. We did something which is hidden. We took the derivative of this. We took the derivative of this. We used the two-fact. That is f plus g prime equals f prime plus g prime, which is the differentiation rule. Okay. We also assumed the derivative of this is the same as the derivative of the t alone. That's another rule. Good news is they are true. Okay, which we'll write it down next time. So from now, this is quick. Okay. That's all for today.